Hi, welcome to Drones Garage. I'm Jacob Orchard, and I'm super excited today because we have Josh Bardwell here, and I'm going to let him introduce himself, and we're going to talk about where we left off last episode of To Be Continued, and we're going to talk about what you really should do to a quad before you actually launch it and test flight it. But first, Josh, introduce yourself. We're super excited to have you here.
Thank you, Jacob. Yeah, I'm really glad to be here. Many of your viewers may know I have a YouTube channel where I talk a lot about quadcopters, tuning, configuring, sometimes even flying them. And actually, I have a lot of background in RF. I actually do RF professionally. My company's Connect 802. We do in-building wireless network design, Wi-Fi site surveys, outdoor point-to-point wireless. If you go back to the very earliest videos on my YouTube channel, a lot of them are me trying to explain RF concepts to RC hobbyists.
Cool.
And then it turned out that, I got it way more into the RC side for the YouTube channel anyway. But yeah, so a lot of background in RF, electronics, etc. And I'm really glad to be here to try and help you guys out and just be on the show.
All right, so super cool. And I'll put a link to Josh's YouTube channel and our show notes and stuff, so you guys could go see it. He's got a lot of super cool information. I know I personally watched a ton of your stuff.
Thank you.
Yeah, to try to look, and I'm fairly new. Like I said, I've only been doing this for like 4 or 5 months, and I have a lot of background in electronics, but not quadcopters is new to me. And so I'm want to see what you're going to show us today, which is super cool. I've done this a few times myself, muddled through it, watched your videos and stuff, but we thought it'd be super cool to walk through what Josh would do to configure the quadcopter the first time, check what checks we would do and what you should do before you take off. So where do you want to start?
Okay, so we've got the quadcopter here, and we've got the Betaflight configurator, and we are running Betaflight 3.0, which I would say if you've just done a build, and one of the questions people ask is, should I run Betaflight, should I run CleanFlight? And some people have a sense that Betaflight is only like for big-time pros, but it's true that Betaflight has a lot of features, a lot of dials and knobs and buttons that CleanFlight doesn't. But if you're a beginner, just leave those knobs and dials alone. I think if you've just built a copter, give it a try, install Betaflight 3.0, leave the defaults alone, do the basic configuration I'm going to show you how to do here, and then see how it flies. And if a lot of times it'll fly really great, even better maybe even than CleanFlight, just with the default stuff, and don't mess with the extra stuff. So Betaflight's a great choice for this build, even if you're not intending to be the next Final Glide or Mr. Steel. So we'll take a look here, and I know you've done some of the basic configuration here. We'll walk through the whole thing anyway, and we'll just double check and see what jumps out. Okay. So here we are in Betaflight. I'm going to go to the ports configuration first. Ports configuration, we have the MSP protocol on UART1. And I'll just give you as many technical details as I think, and you can edit out whatever you want.
we'll just go with it.
UART is the serial port, right? So this board has 3 serial ports. We've got 3 UARTs, and so that's how many sort of serial peripherals we can have.
Right.
MSP stands for the Multi-Wii Serial Protocol, which is Multi-Wii is the sort of great granddaddy of all of these flight controllers that we use. And the MSP protocol is used to talk between the computer and the flight controller. So in this case, MSP is on UART1, and that's because the USB port is also on UART1, and we need that, otherwise we're going to lose the ability to use this configurator to talk to the board, and basically you have to hard reset the board to fix that. So we're going to leave that alone. But if you ever see UART1 has MSP on it, and you think, well, what is that? I don't need that. I'm going to use UART1 for something else. Don't do that. You'll lose your USB connection. Okay. So there you go. Then on UART3, we have our serial receiver, which is we're using the S-Bus protocol with the FreeSky receiver, and so that's being used to receive the data from our receiver, and that's good. You definitely want a serial receiver if at all possible. There's other protocols you can use. One of them is called PPM or CPPM, and then you also have the old style of a way it was done with like fixed wings, where there's parallel PWM, where you have a bunch of wires coming out of the receiver going into, typically going straight to the motors, right? Or the servos, if you have servos. Obviously with mini quads we don't have that usually. And so we definitely want to be using a serial receiver because it has lower latency. There's significantly, maybe half of the latency for a serial receiver versus a PPM or I don't know about PWM, but so that's good.
Okay.
We want that.
Good.
And then we've got SmartPort telemetry here, and SmartPort telemetry is going to let the flight controller send telemetry data back to the receiver, and that telemetry data then is going to come out
Shows
on
up
the
on
Taranis.
Yeah.
Which number one reason that's useful, I think, is for voltage monitoring. Okay, you can do voltage monitoring, and that way, a lot of people fly with a timer. And a timer, you know, I can get 6 minutes of flight time if I'm flying really gently. I get a minute and a half or 2 minutes of flight time if I'm really thrashing it. The timer's not really going to work. It's not accurate enough. So the voltage monitoring is really nice. And I like to use that telemetry even if I have an OSD on a copter. OSD is going to show you the voltage in your goggles, of course, but I find that having it on the Taranis is really nice. Sometimes I get so excited flying that I don't pay attention to the OSD, and having the Taranis say, you know, A1 critical, A1 critical, like, oh, hey, I need to land. And also, it's really nice just to use that. I say it's the world's most complicated and expensive battery checker. So if I need to check a battery in the field, I don't want to put my goggles on, then plug the battery in, and then look at the OSD. I can just sort of pop the battery on here, check my Taranis, and I can see whether the battery's full. You know, if I finish a flight, I go retrieve the copter. I can take a look at the Taranis as I'm picking the copter up and see what my resting voltage is on the battery, see if I've overrun the battery or anything like that. So I like that. It's not mandatory if you have an OSD to run the telemetry, but I think it's a really nice convenience feature. I like it. Okay, so we're all good here. That's all good to go.
All right.
We're going to now move to the configuration tab. There's a lot to see here.
Okay.
So, we got a touch screen. There we go. The first place I'm going to look here, and by the way, you've set up your receiver, so we've got RX serial and S-Bus, and that's correct for the type of receiver that you're using. Depending on what kind of receiver you've got, you might or might not have different configuration here, but that's fine. That's correct. Then, if we take a look, the next place I'm going to look is, I'm going to look here at the system configuration and at the gyro update frequency and the PID loop frequency.
Okay.
And these numbers need to be correct for the type of board that you're using. Depending on which gyro chip the board has on it, it might be able to run the gyro at up to 4K or up to 8K. And that depends on whether it's got the SPI interface or the I2C. I say I2C. I've been told that's not. You're supposed to say I squared C, but I just can't bring myself to do it.
Oh, okay.
So the two different gyro chips that are commonly used, they can have an SPI interface or an I2C interface. The SPI interface can go up to 8 kilohertz. The I2C interface can only go up to 4 kilohertz. And in this case, the board that we've got is the Dodo board, and it's got a gyro that can only go up to 4 kilohertz.
Okay.
So in general, you want to run the gyro as fast as you can, and the reason for that is that higher sampling rates reduce aliasing. Aliasing is a type of corruption of the data, of artifacting of the data that can occur when you're not sampling fast enough. So in general, you want to run the gyro as fast as you can, in this case 4K for our board.
And I believe that when you load this is the default for Betaflight. Does it load to the default for whatever it thinks the board is? Or I don't know.
That's a good question.
Because I've never changed it.
Yeah, that's a good question. So I'm not sure about that. I'm not sure if they all come in at 4K, 2K, or if you had a board that could run at 8K, which would be any board that had the SPI interface, like I said, you would want to change that to 8K, 8 kilohertz.
Cool.
And so we can just, and the interesting thing is, I think if I try to do this now, it'll probably let me do it, but I don't think the board that we've got runs at 8K, so I'm not sure what will actually happen. So we're going to leave that alone at 4K. And then for the PID loop frequency, the PID loop frequency is so every loop, the gyro is outputting data about what the copter is actually doing. The copter is rolling left, rolling right, pitching forward, back, etc. The PID loop is looking at what you're doing with the sticks, and it's saying, I'm sorry. Oh, hold on. Typical. There we go. The PID loop is looking at what you're doing with the sticks, and it's saying, is what the copter is doing in the air consistent with what you're telling it to do with the sticks?
Okay.
And then any difference between what the copter is actually doing and what you're telling it to do, that's called error. And then the PID loop determines what the motors need to do to correct the error, to make the copter do what you're telling it to do.
Okay.
So if the PID loop is running at 2 kilohertz, that means that 2,000 times a second, the PID loop is going to do all of that logic and tell the motors, here's what you need to be doing now. So for example, if the copter is rolling left and it shouldn't be, we'll spin the left motors up to correct that, to generate more thrust on the left side to correct that, etc.
Okay.
So we want to run the PID loop frequency. It's not actually necessary to run the PID loop frequency as fast as you possibly can. And in fact, if we look down here at the CPU load, we'll see that if we run the PID loop frequency too fast, the CPU load will hit 100% and we will have to back it down again.
Oh, okay.
And that's especially true for Betaflight 3.0. It used to be in Betaflight 2.9 and previous, it was much less processor intensive, and we could actually run the PID loop. We could run 8K gyro, 8K PID loop, and we would be at 30% CPU utilization. We'd be fine, right? So since you could do it, why not do it? Run a little faster, no harm. What we find with Betaflight 3.0 is that because it has a lot of new processor-intensive features, we're starting to hit the limits of what we can do with the chip here. We're going to need to go to the next chip up eventually. But for now, we can't run at 8K. Well, do you really need to update the motors 8,000 times a second? Probably not, although that'll be a controversial statement in some circles. But we'll say probably not. So we're okay here with a 2 kilohertz update rate. My thinking is that on a copter that can do an 8K gyro, I'll typically run 8K and 4K for the gyro and the PID loop, and that's fine. If you can't run the PID loop at 4K, you can run it at 2K, and I don't think there's really, I've done some testing and I haven't found any difference in performance, so then why don't I run at 2K? Well, if I can get away with 4K, it's a little more, right?
Yeah.
But if you can only run at 2K, that's fine. So what let's do is let's run here at 4K and 4K, and let's watch the CPU load when I hit save and reboot, and we'll see what happens. And you'll see here the CPU load is now running about 25%, which is probably fine. Now, let's talk about the CPU load for a second, because people say, well, I just installed Betaflight and I tried to arm the copter won't arm. And one of the reasons the copter won't arm is if the CPU load is too high, the software will say, no, I'm not going to let you fly with the CPU load too high, because if I'm in the middle of the air and I hit 100% utilization, something's going to not work and I'm going to have a problem.
Right. Okay.
So you say CPU load 25%, well, I probably have plenty of room here, I'm fine. But actually you may not be, because there's spikes, right? That's just an average, and the spikes are what we're concerned with. So what you could certainly do is you could just try to arm, and if the copter doesn't arm, then you may need to drop back down from 4K. Here we've got 4K, we could go down to 4K 2K, right? But we're probably fine at 4K 4K. What you can do is you can go to the CLI and you can type tasks, and you can see here in the tasks, what I want to look at is the max load. See here, the average is 76. Something doesn't entirely add up about that. It says 76 here, but only 25 there. Our max load is 307. If the max load is over 100, you may still have a problem. We'll see what happens here. I'm surprised to see these numbers with a 4K 4K on this board. We'll see what happens when we try to fly it. But that's certainly something to check. I wish those numbers were made a little bit more, were a little bit more what I was expecting. I'm not really sure why I'm seeing that. Anyway, so there you go. We'll set the loop time for the gyro and the PID loop. Now another thing that we can set here is the ESC and the motor protocol. So let's talk about that for a minute, probably a few minutes.
Okay.
PWM is the old style protocol that was used. It's the same protocol that's used to talk to servos on fixed wings and ESCs, just like back into time immemorial, right?
Okay.
So we've got PWM protocol. Well, in a PWM protocol, the pulse length goes from 1,000 microseconds to 2,000 microseconds.
Okay.
So we've got a 1,000 microsecond on time, followed by a variable on time of another 1,000 microseconds or 0, right? So we can have a 1,000 to 2,000 microsecond pulse. And a problem with that then is that your maximum, that limits the maximum rate at which you can send updated data to the motors, right? If you have a 2,000 microsecond pulse, right, you can't go any faster than that. You can't send pulses any faster than that. So OneShot 125 basically takes that whole scheme and divides it by 8. So now we have 125 to 250 microsecond pulses. And since the pulses are shorter, we can send them faster.
Oh, okay.
Right? And the reason, so why did this never get invented before? Well, if you're just sending a throttle signal to an airplane propeller, how fast do you really need to move that throttle?
Just kind of gradually up
Not
and
very
down.
fast, yeah. But we got a tiny little computer here, and it is sending updates to these motors ridiculously fast, potentially.
Okay.
And there was actually a limiting factor with PWM, a limiting factor in the copter's performance. So the idea is that with one shot, we send shorter signals, we can send them more often, and we can get a more fine control of the motors. Okay. So then we've got other protocols, one-shot 42 and multi-shot, which basically just take that a step further. We've got even shorter pulses with even higher update rates. Okay. If you're flying a multi-rotor, you definitely want to be flying at least one-shot 125. And essentially, all ESCs that you're going to buy today will support one-shot 125 right out of the box.
Okay.
If you don't even waste your time with one that doesn't, but you have a hard time even finding one. Many ESCs today do not support one-shot 42 or multi-shot right out of the box. So if you've got a KISS ESC, that's going to support one-shot 42. If you've got BL Heli S ESC, that's going to support multi-shot or one-shot 42, right? But if you've got a standard BL Heli ESC, it's not going to support multi-shot right out of the box. You can flash firmware to it that will allow it to support multi-shot, but that's a little bit of an advanced move for some people. So using one-shot 125 is fine. You'll get a small performance advantage if you can use multi-shot or one-shot 42.
Okay.
But unless you're tuning the copter right to the edge, if you're really just pushing the tune to the edge, you may find the difference between one-shot and multi-shot. But if you're not doing that, you're probably never going to notice the difference.
And if you're new, like me, and I'm just learning to fly, it doesn't matter.
Yeah.
Right? Stick with 125 and you're good.
Yeah, yes, but also if you have a BL Heli S, and we don't have BL Heli S
These are
ESCs on here.
BLHelis, okay.
These are standard BL Heli ESCs. If you happen to have bought a BL Heli S ESC, use multi-shot. There's no downside really.
There's no downside.
There's no downside, and there may be a small upside.
Okay.
So we're going to
make flying easier for me. Is what you're saying?
Well, maybe. What it'll do is you get these scenarios where you may have oscillations that you're trying to tune out.
Okay.
And with multi-shot, the slightly finer control that the flight controller has may make it able to get rid of those oscillations more effectively. So you may get a slightly wider tuning envelope. But like I said, if you're not really pushing the tuning to the edge, you may never notice the difference.
Okay.
So if you have BL Heli S, use multi-shot. If you have KISS, use one-shot 42. There's no downside. If you have standard BL Heli ESCs, use one-shot. And there's one other thing that's very important to say about that, and that is that because of the one-shot, hang on, yeah, right here, and that is because of the one-shot pulse length, you actually can't go over 2 kilohertz with one-shot.
Oh.
So the reason is that the one-shot pulse gets longer and longer and longer, and eventually it is essentially, it's a 4 kilohertz signal would be on all the time, 100% on time, which means you would lose the timing of it. You would have no, they call it quiescence. You would have no off time to let you keep track of the clock, if you will.
Okay.
So you actually can't run one-shot 42 at 4 kilohertz like I've done here.
Oh.
So in general, 4K is where I would want to be here. But since we're using one-shot, I'm going to need to back that down. And that statement is like with everything. There are a few caveats with that statement. There are things you can do to get away with it. It's called short calibrating your throttle channel, so the signal never actually goes to 100% on time.
Okay.
But we'll take this back down to 2 kilohertz because we're using one-shot.
Okay.
So essentially, we've gone back where we started, but we had an interesting conversation in the meantime.
No,
right?
That's good. That's
okay.
Good.
Okay. So there we go. Let's see. Center value for the RC channels is 1500. That's good. Min throttle 1044. We'll decide if that's correct. We'll find out about that. Max throttle 2000. Min command 1000. What these are the flight controller is going to send throttle values out to the motors.
Right.
Okay. So we need to define the endpoints of that range. And we're just going to, 1,000 and 2,000 is a good place to be. Nice round numbers. I'm not sure if those are the defaults. I know those aren't the defaults in clean flight. They may be changed to the defaults in beta flight.
I think these are the defaults for beta flight.
Yeah.
I know I did change this.
Yeah.
Personally, I've messed with that one. But we can check it again.
Yeah.
All right.
For these ones, it kind of doesn't matter what you use as long as the flight controller and the ESC both agree on where the endpoints are.
Right.
But you can see that if I move those endpoints in, I'm reducing the resolution of the throttle channel.
Okay.
So in general, I think 1,000, 2,000, it gives you 1,000 steps of potential resolution. The actual resolution will depend on various other factors, and they're nice round numbers, and everybody likes round numbers.
Yeah.
So that's a good place for that to be. I'll tell you something I do. I run high volt batteries, and I like to take the maximum cell voltage up to 4.4.
Okay.
The reason is that if you run a high volt battery, the battery will start at 4.35 volts per cell instead of 4.2, which means that if you have the default setting here, it will yell at you and say, oh, your battery's overcharged, and the buzzer will start buzzing at you. So if you're going to run high volts, I like to take that up to 4.4, just so it doesn't start buzzing at me. If you're not going to run high volts, you can leave it at 4.3, which is the default.
Okay.
Let's see, you got your accelerometer turned off. If you plan to use auto level modes, you will need that on.
Yep.
But with this copter, I feel like this. Don't use auto level with this copter. This is an acro racing
I
copter.
used auto level when I first started, just because I was.
Here's what I say about that. If you're gonna fly FPV, bite the bullet. And learn to fly acro.
Yeah, that's
and the
what
reason,
everybody says.
The reason for that, you will end up, acro makes more sense when you're flying FPV, because when you're flying FPV, you are inside the camera, and the stick motions move the camera in acro mode. They move the copter relative to the camera, not relative to the horizon. When you're flying acro, you're not seeing the horizon, if you will. So I think if you're going to fly it, just bite the bullet. Practice in a simulator if you need to.
Yep.
That's very, very worthwhile for a new pilot to spend.
And you explained that to me when we talked on the phone.
Yeah.
Like, it's just the relativity of the sticks to the camera and how you look at it. And it made more sense to me after we talked on the phone before we were arranging all this.
Let's talk about that then. So when you're in auto level mode, the sticks determine the copter's angle relative to the horizon. So as I deflect the stick more, the copter pitches over more relative to the horizon.
Right.
Center stick, the copter centers out. When I'm in acro mode, the stick position corresponds to an angular rate of movement, but not a particular position relative to the horizon. So as I deflect the stick forward, the copter will begin to pitch forward faster and faster, but with no particular orientation implied.
Right.
And the reason that makes sense, when you're flying line of sight, you see the copter, you see the horizon, your head is fixed relative to the horizon, and therefore you pitch the copter forward relative to the horizon, and that sort of makes sense. But when you're flying FPV, you're inside the camera, you're inside the copter. And so what you want to do is you want to move your point of view left, right, up, down. And that's how rate mode or acro mode works. Right. So the problem with that is that when you want to stop, you need to manually level the copter out so it stops moving.
Right.
But that makes it really makes so much more sense. People watch racing videos or freestyle videos, and they ask, "Hey, were you in acro mode when you flew this?" And I'm like, "Everybody's in acro mode when they're racing. No one does that in auto level. So just bite the bullet, get there."
You end up in auto level, where the copter seems to be fighting you. You're moving the stick, and then it moves back by itself because you let go of the stick or you moved it back, and it does things you're not expecting.
Absolutely.
And that's where the confusion comes.
Absolutely. It really does feel like it's fighting you.
Yeah.
It's really hard to make smooth, sweeping bank turns or in auto level mode. I've had experiences where I was flying the copter. In acro mode, when you center the sticks, the copter just stays however it was, right?
Yep.
And I've had experiences where I was flying and I kind of lost video for a minute and it blacked out, and I just centered the sticks and I waited. I crossed my fingers, and the copter, it was just flying. It wasn't doing anything crazy. It was just flying, right? And so the video blacked out, and I knew that if I just centered the sticks and waited, it would just keep doing what it was doing until it came back. Unfortunately, the video came back, and I was flying out in the woods. I wasn't going to crash into anybody, but yeah. It's definitely acro mode, the way to go. Okay. So we've got that turned off, and that's good. You may say, well, I may not use auto level, but why not have it there as like a backup, a safety switch? Some people do that. But having the accelerometer turned off actually reduces your CPU load, and it reduces the jitter in the loop time. It makes the loop time more consistent.
Okay.
So you do want to turn that off if you're not using it. Okay. And then one more thing on this page, I think, before we move on. We spent long enough on this page.
No, it's okay.
Yeah. So one more thing on this page, air mode. So what is air mode? I have a video about what is air mode. let's not go into exactly what it is. Let's just summarize air mode by saying that air mode increases the authority of the copter at low throttle. So if you think about you're raising and lowering the throttle, it's essentially there's a set point that the copter is going to use for where the motors, because if you think about it, if I raise the throttle to make the copter go up, all 4 motors throttle up, the copter rises.
Right.
Right. And if I need to make the copter roll or pitch, then some of the motors will spin up and some of the motors will spin down to accomplish the desired movement of the copter.
Right.
And we can see that that is a function of the difference between the two. If I want to pitch forward, the speed at which the copter pitches forward is a function of the difference between these 2 motors.
Right.
But we could have those 2 motors get faster and slower like that or like that, and we can also take that same thing and slide it up and down the scale. So we could have a case where the motors overall are spinning quickly and we create a difference between the front and the back motors. And the copter will rotate at the same rate, but it's also doing other stuff because the motors are spinning faster. Does that make sense?
Yep.
So what the problem is that when the throttle is very low, the set point for the motors is very low, and so when you then try to make the copter rotate, the motors aren't spinning very fast to begin with, and the copter doesn't have a lot of authority, and you can't make a very big difference between them to get that. So with air mode, there's a change in the mixer logic that gives the copter more authority when the throttle's low.
And authority, you mean basically bite of the props into the air to control it?
Yeah. Well, what happens if you don't have air mode on is if you go up in the air and you chop the throttle all the way down to 0, the copter will kind of go, and it'll tumble.
Right.
And it won't tumble as if the motor's just turned off, but the PID controller and the mixer, the flight controller, just won't be able to spin the motors fast enough to keep the copter stable.
Okay.
And the reason is that you've lowered the throttle, so the set point for the throttle is so low that the motors can only spin up so fast, and they can't spin fast enough to keep the copter stable. If you climb the copter up into the air and chop the throttle, what you want to happen is that the copter just falls straight down, but it maintains its attitude.
Right.
Right.
Okay.
And what will happen without air mode is you chop the throttle, and it just kind of tumbles one direction, which is I think, and for acro flying, you really want to be able to like jump up in the air, chop the throttle, turn upside down, whoosh, gracefully fly over a tree or whatever, right? You really want that. But also for racing, I find that you're going through a turn and you need to get under a gate, right? You're a little too high. You cut the throttle all the way down. You got to drop under the gate.
You
right?
want to fall smoothly down.
Yeah, you don't want the scenario. And I've had this happen when I fly other people's copters and they have air mode off. I'm going and I'm too high and I'm going to hit a tree branch. So I chop the throttle and the copter, instead of going, it goes, right? Air mode is off. Yeah, and I'm like, oh wait, why is it happening? What's going on? So I definitely think air mode should be on all the time. But here's the problem. Here's the downside of air mode. Let's think about when you're trying to land. When you're trying to land, you bring the copter in and you cut the throttle, right? And you disarm. Well, with air mode, when you cut the throttle, now you're at 0 throttle and the copter bangs on the ground.
Right.
Normally, without air mode, it would not have enough. When the copter hits the ground, it's going to try and correct that uncommanded motion. Anytime anything moves the copter without the stick moving, the PID controller is going to try and correct that error, right? So when we're landing and we hit the ground, maybe we hit the right side first, the copter is having an uncommanded movement, and it's going to try to correct that. And what it does is,
yeah, you get the bounce.
It pushes back, and you get a big bounce. So people find landing hard with air mode, and I'll tell you why I think that is. It's because they're doing stick arming. If you do,
I don't stick arm.
Good. I agree. If you do stick arming, in order to land, you have to lower the throttle to 0 and push the stick all the way to the left. And the problem is that for the whole time while you're pushing the stick to the left, you're at 0 throttle and the copter is going bah, 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 or maybe flying, depending on how hard you landed, flying off into somebody's face.
Yeah.
So I think you should just have air mode on all the time, and you should switch arm as you're doing. And then when you're ready to land, you get the copter down within a few inches of the ground, and you just flip the switch. Come back.
My computer went to sleep on you. There you
Yeah,
go.
the screen turned. You just flip the switch, you disarm.
Okay.
You're done. So good.
Cool.
So air mode on, I like it. Alrighty. The next thing let's do is let's go to the receiver tab and let's do some basic checks to make sure that your receiver is
Turn
working
the
right.
receiver on and
A lot of people overlook this and then they wonder why their copter's not flying right. And so we'll do these checks. I think you've already done these things. We'll
I
make sure
actually
though.
didn't change anything on them because
okay.
they actually landed pretty darn close.
Yeah.
Which was surprising to
Yeah.
me because every other copter I've done, it wasn't close at all. So,
Yeah.
so
Let's do-
I can move them around and
Yeah,
you
let's
want
do
to
the check.
explain
So
what we're talking about.
the first thing we're going to do is we're going to make sure that they move correctly, and we can also look at this 3D model right here. But we want to make sure that pitch is pitch, roll is roll, yaw is yaw, and throttle is throttle. So let's just check the channels here and make sure that as you move the sticks, the correct stick is moving. So that's the roll stick, pitch stick,
pitch stick,
yaw stick, yes, and throttle. Okay, good. Now if that is not correct, you can fix it with the channel mapping.
Right, and we
Okay.
did this in
Okay.
part 4.
Okay.
Right, I had Golden Oz change this because
Okay.
defaultly it comes up in the Free Sky wrong, and then you change it. So
Okay.
we walked through that.
And then have you also checked the endpoints?
We did. So I did it off camera.
Okay.
So we can
Let's do
explain
it
what
off-
we're talking
yeah.
about as far as endpoints go.
So as far as endpoints go, CleanFlight expects the channels to go from 1,000 to 2,000 microseconds. And if you are not feeding it a signal that goes from 1,000 to 2,000 microseconds, then either you will not achieve full deflection, so your rates won't get as high as you want them to be, because CleanFlight will not perceive that you're deflecting the stick as far as you actually are.
Right.
Or if they go off the end too much, you'll have a dead band at the end of the stick travel because you will reach full deflection before you actually have fully deflected the stick.
Right.
So essentially what we want to do is we want to deflect each of the sticks all the way to the one side, and it should be 1,000,
Yep.
and then go the other way to 2,000, and that's what we want to see. And then in the center we want 1,500. 1,501 that's
Yeah,
acceptable.
it-
Now, the exact way to fix that depends on your transmitter, but in general, you're going to want to look at your transmitter's endpoints, and then if your transmitter has sub-trim, that's the way to fix the center.
right.
So we'll check all the channels. Pitch, 1,000, 2,000, perfect. 1,501, fine, good enough. 1,000 to 2,000, and throttle, 1,000 to 2,000. Good. Center doesn't matter so much for the throttle because it's not spring-loaded, but okay.
And I was surprised. I have not adjusted these at all. It's the first
Yeah.
copter and receiver combination I put together where they were
just dead
that
on.
close, dead
Yeah.
on. I was like,
Yeah.
I didn't even need to adjust them.
You typically do need to adjust them a little bit.
Typically you do, and
Yeah.
I was like, I was shocked. I'm like, normally you're on the transmitter and you're
Yeah,
adjusting
yeah,
it,
tweaking
and
it around.
tweaking it around to get the endpoints right. And this one, for whatever reason, just
Just
lined
perfect.
up perfect.
Yeah.
I was like,
I
wow.
usually have to take the Tyrannus to like 97%. It's usually a little bit too high.
Yeah.
But yeah, it works, it works. That's what really matters. And then we're not going to do that for the aux. You see the aux channels
Yeah,
here.
the
at
aux
nine.
channels,
It doesn't matter for the aux channels because they're not we're not doing sort of real-time, sort of gradual stuff with them. Everything we're going to do with the aux channels, we can work around that. So we don't need to bother setting the aux channels. Okay. Let's see what else we got here. That's, I think, everything. There's other stuff there, but nothing major that I check every single time. We're going to go to the modes tab. You've set up your ARM mode right here.
right there. And so the way I did it, and this is from another guy in our chapter told me this. So normally I think people are just one switch to ARM, right?
Yep.
And he was like, "Oh man, I did that, and
Yeah.
I accidentally bumped it while I was reaching down to grab my copter."
That happened to me.
Poppers came on. So
Yeah.
he loaded it on here. I don't know exactly what it is, but essentially what it does to turn on aux 2, I actually flip this switch up
Yep.
and then the momentary switch.
Yeah.
And
So I call
the
that-
logic on here, throttle has to be at 0.
Yeah.
And then the switches, that way you can't accidentally arm
Yeah.
it by default. And then to disarm it, just
Yeah.
flip the switch off and
I fully agree with all of that. In fact, I have a video on my channel. I call it sticky arming that
Okay.
describes how to do that with your Tyrannus. Maybe even he's used
Maybe
the same
he's
logic.
used
Who
the
knows?
same one, I don't know.
I'll tell you what. I'll tell you some things about that, about how I set up the Tyrannus. So if you have a Tyrannus, this switch here, switch SF, that is usually where the throttle cut is. If you go all the way back into time immemorial,
Okay.
this big shoulder switch here. Some radios, I think Futaba radios, put it on the right side. So whatever, you've probably got a big 2-position switch here, and that's what I like to use for the arming switch. And what I like to do is I like to have the forward position be disarmed.
okay.
And the reason for that is that when I arm, I put my finger on the switch, I flip it like that, and now I'm armed and I'm flying. If I'm flying and I need to disarm in a hurry, I can just flip like that and it's off, right?
Okay.
Whereas if I have to if I did it the other way, some people like to do it the other way because they feel that the default position for the transmitter is that all switches away
Right.
is sort of the neutral default position. And if that was true, then away would be disarmed. But I don't like to do that. I like forward to be disarmed because I don't want to have to be going when my copter's flying somewhere crazy, flipping out,
Okay.
you know, whatever. I just want to go and it's disarmed. So
Okay.
I like forward to be disarmed. The other reason for that is that when I'm holding the transmitter, I can just rest my, and I learned this from flying fixed wings,
Okay.
you can just rest your finger here and you know that it's disarmed and it's not going anywhere. And when you're ready to arm it, then you just flip it. Now I do like the 2 position. That's great. That's how I have mine set up. I feel like that if you're going to do switch arming, you definitely should have some safety procedure because it is too easy if you just have one switch to accidentally flip that. Your transmitter's dangling around your neck. This happened to me once as well, and that's where I was like, I have to do something different. It's too easy to just flip that and whoosh, your motors are spinning.
Yep.
So definitely set up a what I call it sticky arming switch. The other thing you can do if you don't have a, what if you have a, you don't have a Taranis, right? You can still set up the switch, and what you do is when you disarm, you raise the throttle. The copter will not arm if the throttle is raised. So now with the throttle raised, that's my safety.
Okay.
If I accidentally flip the switch, the copter will not arm. Okay? So if you don't have the ability to set up this complicated 2-position double switch sticky arming thing, then get in the habit of every time you disarm the copter, raise this throttle.
Okay.
And now you're safe.
Yep.
Okay?
You
And then-
don't want it to come on
No,
accidentally.
you don't. You don't for sure. So you've got that set up. You've got your arming mode set up, and I always will test that. Go ahead, just test that one time.
Okay.
Here, the channel is showing us our current channel value, and now we've gone. The channel has gone into the arming range,
Right.
and arm has turned orange. That tells us that we are actually armed. If your channel goes, see this indicator here, if that goes into the arming range, and this doesn't turn orange, you're not arming. Something is preventing you from arming. It could be CPU utilization. It could be, it's called small angle is the parameter. The copter won't arm if it's not level. Any of those things. But if you're having, go ahead, turn that off. We got haptic feedback. Hollering at it. If you're ever having trouble with your copter arming, one of the basic checks you can do is you can go to the modes tab, you can arm the copter, and if this doesn't turn orange, something's preventing you from arming. Okay. If this does turn orange, but the copter still won't fly, you at least know that the flight controller thinks that you're armed, and you got to figure out why else you can't fly.
Yeah, and I will say the first time that I tried to do this with this copter, we were in here and armed it, but the props weren't spinning, and I was like, wait, it's not armed, and it was that scenario. Like I wasn't sure if it was armed or not, and then turn it all back off, and then go back and check it again because I'm like, okay, because you do want some indication that it is armed.
Right, and there's the LEDs will change as well, but it's not always clear what's what.
And depending on where the board is inside your
you
copter,
may not be able to
it's
see it.
hard to see it.
If you try to arm, if at any point you have a slow, I don't know if we'll be able to catch this on camera, but we've got, it's different for different boards. I think it's this red LED. Come back. I think it's this red LED here. If that's ever slow, if you ever have a slow flashing LED, sometimes it'll be red, maybe it'll be a different color depending on what board you've got. A slow blinking LED, it means that there's some condition that's preventing you from arming.
Okay.
And the most common things are your CPU utilization is too high, or if the copter is not level, it won't arm because it doesn't. You might be carrying it in your hand or something.
Okay.
So if you ever set your copter down and if you're like on a little bit of a hill and it won't arm, that could be it.
Or if you're a bottom battery mount guy, you set it like this on the battery. Sometimes it's too much of an angle.
Yeah.
Right.
Yeah.
Okay.
I think 25 degrees is the default angle.
Cool.
Okay. Do you have a? I can't remember. Do you have a buzzer on this one?
We purposely didn't attach the buzzer because of the show. Because we're like,
Right,
ah,
you don't want to beep. Okay.
beeps all the time.
I recommend, and not for if you're building one for TV, then that's different. But I recommend that you have a buzzer,
Right.
Because number one, the feedback you get, it tells you you're armed, it tells you your gyro is calibrated. But the number one reason is that when you land or crash and you're out in the middle of a field or you're up in the top of a tree, the buzzer is going to help you find your copter. And
eventually I'll put the buzzer on it.
Yeah.
I just didn't do it because for the show it's annoying.
So I would always also set up a beeper range so I can trigger the beeper with a switch.
Right,
on
and
the,
actually
on the Taranis.
what I normally do is this momentary switch is also the beeper.
Sure.
So
sure.
when you arm, it's beep, 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 beep.
Yeah.
anyway, because the beeper, and even if I don't want, even if it's crashed and the radio's on, I can flip the switch and the
Yeah.
beeper will come on.
Now here's
right?
here's the potential problem with that is you're
Okay.
also using that switch for your sticky arming, right?
Right.
So I wouldn't want to overload the I want the arming function to be in a broom by itself. I don't want to. And what are the chances of this happening? But I don't want to be trying to make the buzzer go and accidentally arm the copter. And you got plenty of switches on that thing. You got more switches than you're ever going to use. Just pick a spare one and use that for your buzzer is what I would say.
Okay.
So I leave the arming function in a room by itself. Never want to accidentally arm the copter and have a problem. All right. So that's good. We're doing good.